Hi there everyone, and welcome to this evening's revision webinar on the challenge of natural hazards. My name is Karen. I work for Discover the World Education. I was previously a geography teacher for over 20 years, and the purpose of these sessions is to basically give you sort of quite a focused revision session from someone who's not your geography teacher. This will give you the opportunity to really sort of enrich and enhance your knowledge and understanding. Ask any questions. We do have the chat function, which I can see that some of you have been using already. If I can ask you to keep the questions in there relevant to the webinar, that would be fantastic. I will try and answer as many as you have in there so that we can really help you along with your revision this evening. So as I said, tonight I'm aiming to give you a focused revision session on natural hazards, specifically volcanoes and earthquakes, plate tectonics, the theory behind that. And then tomorrow at 8 o'clock, we're actually going to follow up the session by looking at a case study, looking at Iceland, and a case study for volcanoes and earthquakes. Also, how Iceland monitors and prepares for the risks associated with tectonic hazards, and then again also why people still continue to live in Iceland. So let's focus on today. Over the next 30 to 40 minutes, you will look at the main objectives that we have here. And also, in addition to that, I'm going to give you plenty of opportunities to see where you can really think like geographers, as well as extend your sort of confidence really on writing like a geographer as well. And there's plenty of opportunities on the slides for you to see where you should think like geographers, where you can think like geographers, how it's best to write like a geographer. You always need to keep these 2 points really in mind when answering your questions in your exams, because using keywords and extending your points to use the different geographical sort of themes and topics will really increase your marks, make your answers slightly better. And I hope that I can give you lots and lots of tips on that. So what does it mean to think like a geographer? So thinking like a geographer means that you're looking at the different angles that we study in geography. You're looking at the human, the social, the environmental, the physical, the political, at different scales over time, using data, statistics, and examples, and then applying this knowledge and understanding in your answers to different scenarios. And really show the examiner that you are a geographer, that you have an interest in this subject, and that you have an understanding of this subject. To write like a geographer, you need to know and understand your key words. And I'm sure your teachers are always saying to you, use more geographical terminology, use your key words. And I can't really sort of like enforce that enough. It really is very, very important. So know and understand your key words and then use them. Use them when you're talking in the classroom, use them when you're doing your revision, and most importantly, use them when you're doing your writing, because then you are showing that you understand that geographical terminology that's so important. Use it correctly and use it effectively in your answers. As I said, please use your chat function, the chat function here. I do have a colleague of mine, Kat, who's sitting in the background, so she will relay any questions over to me. If I can ask you to keep the questions relevant, it really will help me and Kat to sort of like distinguish with those questions. And for those teachers who are here, this session will be recorded and it will be available on our website and on the YouTube channel as well. So you can use it afterwards, or please do share the link with your students as means of a revision tool, sort of like moving forwards. Okay, so tonight we're going to look at what are natural hazards, the types of natural hazards, the factors affecting hazard risk, and then really look in detail at earthquakes and volcanoes, plate tectonic theory, the distribution of earthquakes and volcanoes, and then look at that in terms of the relationship to plate margins and what happens, those physical processes that happen at plate margins. So what are natural hazards? Natural hazards are extreme natural events that can cause a loss of life, extreme damage to property, and disrupt human activity. Examples of these: an earthquake, an avalanche, a tsunami, and then here we have a tectonic or a volcanic hazard. And natural hazards can actually be placed into two main categories. We have tectonic hazards, and then we also have climatic hazards. And examples of climatic hazards could be flooding, tornadoes, hurricanes, and drought. And then one that I haven't mentioned particularly on here, but we will look at in a little bit further on in this webinar, forest fires. And I think forest fires this year, particularly in Australia at the beginning of the year, and then more recently on the western coast of the USA, forest fires have actually been quite an extreme natural hazard that has happened this year, alongside everything else that is unprecedented and extreme that has happened this year. Forest fires just seems to be sort of like one of the things that is happening. We just had a question in the chat box about asking what year this is for. I would say this is mainly focused on GCSE, but also upper key stage 3, and also if you're an A-level student, it may reinforce some of those sort of like foundations of the geographical knowledge and understanding that you need for natural hazards. Okay, I hope that's answered that particular question. Okay, so let's carry on now. Now, when it comes to looking at natural hazards, we have to look at the factors affecting risk, because a natural hazard in itself, unless there is a risk associated with it, okay, it doesn't really pose much of a hazard, okay? So we have to look at human activities and how they influence certain natural hazards and how they occur and how severe they are. Understanding when, where, why, and how natural hazards occur can help us really understand how to minimize their impact on our lives. Okay, and that is really, really important, because what we are looking at here is the risk to human, the risk to sort of like property, the risks to towns, to infrastructure, all of that sort of stuff. That is what we're looking at. We're looking at the risk. Okay. So we really have to understand this, and the management and preparation can help reduce the risk. This is something that we're going to really look in a lot of detail tomorrow when we focus on Iceland. But just as an overview, looking at the risk today, we need to look at what factors affect risk. Here it is really important that you know your keywords and also start to really think like a geographer. Looking at all the different aspects. Use the keywords, know what they mean. So urbanisation, okay, as the population grows, more people are exposed to natural hazards. And as geographers, we really need to consider this. Urbanisation, the built up areas where you've got huge amounts of people in a small number of space. Is the area densely populated? That means there's lots of people in a small area. Or is it sparsely populated? That means you haven't got too many people living in an area. Okay, and this risk will really be dependent on whether an area is densely or sparsely populated, and you need to weigh up the risk. We also want to look at the level of economic development, whether a country has got high levels of poverty, whether it's a high income country or a low income country. It's important that you use those key words. Okay, using sort of like developed, developing countries is kind of a little bit out of date now. So try and use the new terminology: low income countries, high income countries. Okay. Ask why. It's really important as a geographer that you start to ask why, and also look at how as well. Really, really important. When you're thinking like a geographer, consider things like the infrastructure, the emergency response, the monitoring, the prediction, the healthcare, the money. A question could be, could Japan cope with an earthquake better than Haiti? Why do you think that? Can you start suggesting reasons why? So you might want to think about, is it densely or sparsely populated? What is the level of economic development? Are there sort of lots of areas suffering from poverty? Is it a low-income country or is it a high-income country? These two photos here on the side, they show an earthquake area, sort of like an area that has been damaged by an earthquake, and it shows a volcanic eruption. The top one is obviously quite a densely populated area, so the risk here was obviously very, very high. The risk at the bottom photo, where you've got the volcano where you can't see any population, towns, or no evidence of it in any case, that's obviously a sparsely populated area. So you've got to really weigh up the risk here. You need to determine, by thinking like a geographer, which factor is the most important by assessing the risk and looking at the evidence that you can see. We can make assumptions and we can suggest reasons. Okay, we need to apply our knowledge and understanding to sort of try and determine the answer here, because we don't really know, but we can make assumptions if we use our brain and think like a geographer. Two other factors that we want to consider here: farming on nutrient-rich floodplains. As population increases, the land becomes sort of few and far between, so therefore it's quite tempting for people to farm on these nutrient-rich floodplains. And we know, because we're sort of intelligent geographers, that floodplains are called floodplains for a reason. There is a chance that they are going to flood. So therefore, if they're living on these floodplains and farming on these floodplains with an increased risk of flooding, there could be a higher risk. And then something which I know as sort of like, really forward-thinking students that you're considering all the time, climate change. There has been increasing extreme weather events over the last few years, definitely. I mentioned right at the beginning about forest fires, and then also there's been quite an increased amount of flooding as well. And these are all factors affecting risk. Okay, it can happen in LICs, it can happen in HICs, and you need to weigh up these things, determine which one is important. We've had a question here about vulnerability and risk. Vulnerability is whether or not the people in that country are vulnerable. Have they planned? Have they monitored? Are they prepared? Okay, if you have planned, monitored and prepared, then you can be ready, and you are sort of being prepared for that risk. You are assessing that risk, and you are hopefully in a position to be able to sort of like manage that risk. Okay, so that's the difference between the two. I would say that the people here on the left-hand side are quite vulnerable. Just by looking at that image there, okay, they do look quite vulnerable. They're rescuing themselves, so they're quite vulnerable. Okay, the risk on the right-hand side here, we don't know what the risk is because we can't see where the population, where the towns or anything like that is. Okay, I hope that answered that particular question. So let's move on now to earthquakes and volcanoes. It's important to know and define and understand exactly what an earthquake and what a volcano is. So an earthquake, it's a sudden violent period of ground shaking. Most occur along tectonic plate boundaries, for example, the San Andreas Fault on the west coast of USA. Notice here that we are thinking like geographers. We're giving examples, we're using keywords, all right, and we're showing all the information that we have. Friction and sticking between plates creates pressure and stresses which build up to breaking point, and the sudden release of that pressure and that stress causes the earthquake. Okay. And then we have volcanoes. So volcanoes, large, often cone-shaped landforms formed over long periods of several eruptions. They're fed by molten rock, magma, deep within the Earth's mantle. Most occur in belts along plate margins, for example, the Pacific Ring of Fire and the Mid-Atlantic Ridge, and some occur at hotspots where the crust is thin and magma breaks through, for example, Hawaii. Okay, Again, use those keywords and know what they mean. Now, I can see there that a question has come through around about forest fires. So what I'm going to do is I'm actually going to keep that question there, and I'm going to answer that one at the end just so that I can come back to it, if that's okay. Okay, so let's now look at plate tectonics theory and the structure of the Earth, okay? If we look here, the Earth is broken up into four main parts. We have the crust, we have the mantle, we have the outer core, and we have the inner core. The crust here is what you and I live on, and is by far the thinnest layer of the Earth. The thickness varies depending on where you are on the Earth. The oceanic crust is generally 5 to 10 kilometres thick, and the continental crust, which is the mountain ranges here, is between 30 and 45 kilometres thick. The thin oceanic crust is denser and heavier than the thicker continental crust, and it floats slightly lower in the mantle. In very broad terms, oceanic crust is made up of basalt, whereas the continental crust is made up of rocks actually quite similar to granite. Okay, I've had another question here. What's the difference between a volcano and an ice fire? I'm not sure you can get an ice fire, but we are going to cover tomorrow about volcanoes that erupt underneath glaciers. So maybe that answers that particular question. So we can look at that, okay, tomorrow. Below the crust is a solid, relatively cooler proportion of the upper mantle that's combined with the crust to make the lithosphere layer. Notice that we're using some key words here, lithosphere. It's important that you use these in your answers. And this layer is around about 70 to 100 kilometres in depth. Okay. Below the lithosphere, we have the asthenosphere. This is much hotter, and it's a malleable portion of the upper mantle, and it's around about 700 kilometres in depth. This layer is really important. It acts as the lubricating layer that allows the lithosphere to actually move. The mantle is the area below the crust, and it's by far the largest volume of the Earth's structure. It's around about 84% of the Earth's volume, actually, so it is a huge area. The outer core is a liquid, largely iron layer that lies below the mantle. It's around about 2,300 to 2,900 kilometres thick. It's believed to be about 80% iron with some nickel and a number of other different lighter elements. It's hot enough to be molten, but it's not quite under enough pressure to make the iron that's in here solid again. Scientists believe that the temperature here is between about 4,000 and 5,700 degrees Celsius. Okay. The inner core is the centralmost layer. It's similar to the outer core. It's made up of iron and nickel again, but the radius is around about 1,200 kilometres. The difference between these two layers is actually mainly density driven. The pressures are high enough on the inner core to make the core solid, and it has the added enrichment of gold, silver, platinum, palladium and tungsten, which are all quite heavy elements. And the combination of that and the pressure that the rest of the Earth sort of like is actually makes this central core area quite solid. Temperatures in the inner core can reach over 5,400 degrees in Celsius, and the pressures are up to 360 gigapascal, which is massive. The same temperature here as the surface of the sun. I've got another question here. Is tomorrow's session only about Iceland? Yes, it is. It's using Iceland as a case study, which is a really important case study for lots of different elements. So yes, tomorrow's session is just about Iceland. Let's just continue now with plate tectonics theory. Okay. The plates move because they are carried along by these convection currents in the upper mantle. Hot rock rises. When it reaches the surface, it cools. it becomes heavier, and then it starts to sink. And this circular movement that you have here actually moves the plates very, very slowly, very, very gently, and it moves these broken up areas of the Earth's crust. Okay, now sometimes when these plates get stuck and the pressure builds up because underneath it is still moving, that is when you're at risk of an earthquake, because that pressure can suddenly be released, and that's what causes the earthquake. Okay. The same process that can be seen in these convection currents in the mantle can actually be seen in some boiling water, and we're going to look at that in just a minute. And you can actually do this experiment in your kitchen at home if you have a glass saucepan or something like that. When you are talking about plate tectonic theory, it is really important that you use some of these key words here. So when you're talking about the movement of plates, use the words divergent, convergent, or transform. Or you may also hear the terminology constructive, destructive, collision, or conservative. These actually do mean the same, okay? Not convergent and collision, they are slightly different. We'll look at the difference between those, but a divergent constructive plate margin is generally the same, okay? Now, I've just had a question here, do plates not move by slab pull? Yes, they do. They do, but it is the convection currents that actually cause the slabs to be pulled and to be pushed. It's the convection currents actually in the mantle. It's that movement that's moving it. And can an earthquake lead to a volcano? Yes, it can. It's magmatic movement. So that magmatic movement underneath the volcano can actually cause sort of like a movement in the magma chamber to disrupt the balance in the magma chamber. And yes, it can. And sometimes a volcano can sort of like make sort of small earth tremors as well. So they are quite closely linked, okay? But we'll look at volcanoes and earthquakes in just a minute and look at the difference between the two. But obviously there are some similarities between the two in terms of the processes around them. Okay, so let's look at our saucepan of water. Okay, so we have the heat underneath, rather like the heat in the mantle. Okay, and then we have the convection currents moving here. All right, so the water rises, it cools, it gets heavier, and it falls down, and that convection current happens all the time. Okay, so you can see real different, real similarities to that here. Okay. So let's look at this map. The Earth is split into 7 major plates and several minor tectonic plates. And here you can see on this particular map, you can see the outline of the plates. And when plate tectonics theory was sort of like being discovered, they plotted where the earthquakes were and where the volcanoes were. And as you can see, there is quite a sort of like a real correlation, positive correlation between where the earthquakes are, where the volcanoes and the volcano belts are, and where the edges of the plates are as well. So, there really are some very, very close links here. Now, key words that you need to know here, okay? Distribution. Where are the volcanoes? Where are the earthquakes? So if we were talking about the distribution of volcanoes, we could say that they are along the western coast of North and South America. They lie in the middle of the Atlantic Ocean, okay? They are in clusters. They are in belts. They are on the Pacific Ring of Fire. Occasionally, like Hawaii, for example, then we're looking at hotspot volcanoes as well. Okay, really important. The Mid-Atlantic Ridge, the Pacific Ocean. Okay, and you use examples, Hawaii, Iceland. Okay, so make sure you know these keywords when you're looking at where volcanoes are, where earthquakes are, how they link to the plate margins. Make sure that you use these sort of keywords here. I've got a question here. Is it possible that tectonic plates are divided into smaller plates like Nazca and Cocos? Yes, they are here. We have here the smaller plates. As I said, there are 7 major plates and then several little minor plates sort of spotted around. You can see here between the Eurasian and the Arabian plates, there are actually several smaller ones here. And then you've got the North American, South American, you've got the Pacific plate here, which is probably the major-most plate in here. And then obviously you do have the smaller ones as well. I hope that answers that particular question. Okay, it says, why is the north side of the Pacific Ocean covered with volcanoes, hence the ring of fire? Not quite sure what that question means, but we do have lots of volcanoes here, and that's all to do with the fact that there is a destructive, a convergent plate margin here. And we're actually going to come on to that next. So I hope that that is going to answer this particular question. Whereas what is happening here is the Pacific plate, is moving this way. Okay, I think you can see my cursor. The Eurasian plate is moving this way. So therefore this plate is being dragged underneath the Eurasian plate. And this is why you've got a destructive plate boundary here. Whereas on this side of the Pacific plate, you've actually got a few volcanoes, but not quite so many. And that's because the plates here are moving side by side. So you've got a transform plate boundary here. Okay, so I think that answers that question, but I think quite possibly my next slide is going to help with that particular question. Okay, so teachers often show this big diagram which kind of shows every single possible plate boundary that we have. And what I'm hoping to do is to actually break this diagram up for you so that you have an understanding of the 3 major plate boundaries and that you'll be able to understand those 3. But as you can see here, we have a convergent plate boundary, which is where you have actually got the subducting plate here, which is the oceanic plate going underneath the continental plate. You've got the divergent plate here, which is where you have got the 2 plates moving apart. And then you've then got sort of a transform plate boundary where you have got plates moving side by side. Okay, let's move on now, one slide. Okay. We have here a picture of a destructive plate boundary. And we have the oceanic plate going underneath the continental plate. Someone's asked a question about Hawaii. I will talk about Hawaii in a minute because it's a hot spot, so I will talk about that in just a minute. So here we have got a destructive convergent plate boundary. For example, the Andes Mountains in South America. So 2 plates move towards each other. The west coast of South America, for example, the dense oceanic plate is subducted beneath the less dense continental plate. Friction can cause strong earthquakes, and the sinking oceanic plate creates a sticky gas-rich magma. This results in steep-sided composite volcanoes and quite violent eruptions. Now you will notice on a convergent plate margin, we get earthquakes and we get volcanoes. It's very important that you understand that this is the only plate boundary where we generally get both of quite high magnitude. Now, when we have 2 continental plates meeting each other, there's no subduction, which means the plate is not going underneath. So therefore, there's no magma being disrupted. So therefore, there's no volcanoes. But the crust does crumple and we get fold mountains, for example, like the Himalayas, and we get powerful earthquakes which can be triggered. Okay, so this is a destructive or a convergent plate boundary. Okay, oceanic plate going under the continental plate. This disrupts the mantle, causes quite a lot of movement in the mantle, triggers an earthquake, and can cause a volcano as well. Okay, so the question was, why does Hawaii have a volcano because it's a hotspot and they didn't understand why. Sometimes hotspots appear where you have got weaknesses in the Earth's crust. I'm actually going to go back a slide just that you can see. So you see here, you've got the Pacific Ring of Fire, and you have got the Pacific Plate, which is being pushed and pulled from all around the edge of the plate. If you imagine that you've got a piece of pastry and you are pushing and pulling it from different angles, quite often you will get a weakness in the center of your pastry. And that is exactly what is happening here. You've got a weakness in the center of the plate. In addition to that, you have also got quite a large magma chamber sitting underneath Hawaii, rather the same as you have actually got in Iceland. Okay, so the combination of a thinner crust, okay, as well as a magma chamber leads to these particular hotspots. I hope that that answers that particular question. Okay, so let's move on now to a divergent or a constructive plate boundary. And here you have actually got the plates moving apart. Okay, so two plates move apart, magma forces its way to the surface, the crust breaks, so you get mild earthquakes, but only mild. But the magma here is very hot and it's fluid, so it flows quite a long way. And you do often get broad and flat shield volcanoes, for example, in the Mid-Atlantic Ridge in Iceland. Okay, a constructive or a divergent plate margin is quite an easy one to understand. Okay, and it causes the Mid-Atlantic Ridge. So you've got this fantastic example as well. Okay, let's move on to the next one, which is the transform plate boundary. Here you have got plates moving side by side, and they can move in the same direction but at different speeds, or they can move in opposite directions. And the stresses and the strains between the two plates can cause friction and pressure, which can cause earthquakes. In the center of the earthquake, you have a focus actually underneath the plate, and directly above that you have the epicenter, and then you have the seismic waves running out from the side there. Okay, let's move on. Examples of these, sorry, I forgot to say about an example of these, San Andreas Fault. Okay. So let's now look at some questions that you might get in an exam. Okay, quite often they will show a map, and this particular one shows exactly the same map as we had before, actually, showing the edges of the plate boundaries. And a question might be, which one of the following statements is true? Okay, so in terms of this one, you've got 4 examples there, and you need to decide which one you think is true. Now, with multiple choice, I always say to my students that I recommend that you suss out the answer yourself before you actually sort of like look at it, because I often find that a lot of my students actually sort of get confused by looking at multiple choices. So, you know, yes, look at them, but make sure you try and find the answer yourself first. So shade 1 circle only. All active volcanoes occur in lines along plate boundaries. We know that's not true, because we know that there are hotspot volcanoes, for example, Hawaii, which is not on a plate margin. Okay. B says there are more active volcanoes along constructive margins than destructive margins. Well, I don't actually think that's the case. I think, you know, they're equal, aren't they? We've already decided by looking at our information from before that we do get volcanoes along constructive and destructive plate margins. Okay, there are many active volcanoes around the edge of the Pacific Ocean. Well, we know that is actually true, so we're going to keep that one in the back of our mind. And then active volcanoes are found along the eastern side of North and South America. Okay, well, actually they're not, because they're on the western side, aren't they? So we know that C here is actually the right answer. Now, please make sure that you do only circle one of those boxes, okay, because you won't get any marks if you put a cross or something like that. Just make sure that you do actually circle. I know that sounds obvious, but it's amazing how many exam papers that I've actually marked and they've put a cross or they've circled the box or stuff like that. You just have to make sure that you actually just shade one circle only. A question here, it's a very simple question, but it's often done wrong because people don't actually read the question. And I really would say to you, please read the question. Describe the movement of plates along plate margin X. Plate margin X you have got here, okay? It's not asking you to explain, it's asking you to describe. So you are saying what you see. So we know here that it is a destructive plate margin, okay? So we know that we have got plates coming together and we have got one plate being subducted under the other one. So it's important that you just describe what is happening at margin X. You don't need to explain. You don't need to explain plate tectonics theory at all. You just need to describe what is happening. I've got a couple of questions here, and I would like to come back to those if that's okay, just that we can focus on this particular question here. All right, so make sure you just describe, don't explain. It's just worth 1 mark. So 2 little points, that's all it's asking for there. Okay, this one says, study figure 2, a map of Iceland showing the tectonic plates. The area is labelled Y on figure 1. Okay, so if we go back to figure 1, it's here. Okay, and then here we have this. The first question is, how long will it take for the plates to move 100 meters? Here you have to find your variable. It tells you that the rate of plate movement is 2.5 centimeters per year. So you need to work out how many centimeters in 100 meters, okay, and then work out how many years. All right, so it would be 10,000 divided by 2.5, and your answer is 4,000. So it's quite simple maths there that you can do. Okay. Next question. It says, using figure 2 and your own understanding, suggest how plate movements cause tectonic hazards in Iceland. Fantastic. A 6-mark question. This is where you can really show that you can think and write like a geographer. Okay. They've given you something to work from. They've given you figure 2. But they're asking for your own understanding. This is where you should get excited, okay? As geography students, you think, fantastic. The examiner is asking me to show what I know, to show what I have done in class, to show all those webinars that I've been to show that extended reading that you have done. And it's given me a hint by saying, using figure 2, it wants you to talk about this particular country. This is from the 2018 exams. So just to give you an idea as to where this comes from. 6 marks, fantastic, okay. And in order to get a level 3, your responses need to be quite detailed. You need to use keywords. You need to think like a geographer. You need to apply your knowledge, your understanding, okay. Now, the next slide actually has a lot of writing on it, and I'm sorry about that. But I hope that you can either screenshot it or maybe take a picture of it to help you. It was the only way that I could get all the information on there. So here we can see, we want you to show that you have the X factor. What have you got that somebody else hasn't? What can you show the examiner that makes you stand out of the crowd so that you actually get that level 3? So the command word, if you remember from this particular question, was using figure 2 and your own understanding, suggest. That's your command word. So your responses should be set out talking about the likely causes of volcanoes and earthquakes from the source, all right, and show an understanding of the processes. So we want you to talk about push and slab pull processes. We want you to talk about the movement of plates, subduction caused by convection currents. I will tell you this is from the AQA exam board that these exam questions have come from, and then I've got some edXL ones coming up, okay? You should have an understanding that the processes cause volcanic activity at margins, all right? The fact that two plates move. You need to explain your divergent plate margin, the fact that magma rises through the crust and that sometimes you get volcanoes. You might also talk about the fact that you get earthquakes here as well, but they're generally of low magnitude, which means they're a lot weaker. All right, you need to talk about the hazards. It's asked of you to talk about what happens here, your own understanding, okay, of how they cause tectonic hazards. So talk about tectonic hazards. It wants you to, okay. You can talk about volcanic ash, the glacial flood, the lava flows, the fact that you may get earthquakes. You can then also talk about some indirect hazards, talking about crop damage. Maybe it's going to cause a problem in the future. You could talk about a fantastic example. We're going to look at this tomorrow, Eyjafjallajökull in 2010. So you can actually add that in as well, okay? And then, important, apply your knowledge and understanding. Talk about how Iceland sits right on top of the plate margin, okay? And that, you know, this is where the volcanoes and earthquakes happen. You don't have to write all of that, okay, but developing some of your points, using those keywords, applying your knowledge, really showing the examiner that you know what you are talking about, okay. So moving on then, another question. This one comes from an edXL paper. Describe the global distribution of earthquakes and volcanoes in relation to plate margins. They're not giving you a map. They're not giving you anything to sort of like give you sort of like some hints and some clues, but you should know, you know what distribution is. You're basically saying, where are they? And this one is saying, where are they in relation to plate margins? So it's only worth 3 marks, so you can write 3 descriptions because the command word here is describe, okay? Or you could just write 2 and then develop them a little bit further. And some of your answers might be the distribution of earthquakes and volcanoes is not random. They do have a relationship with plate margins. They both occur in narrow bands along the plate margins. And earthquakes are found at all types of plate margins, constructive, destructive and conservative, or convergent, divergent and transform. All right, and volcanoes are generally found at divergent and convergent. Notice how I changed the words there, okay? There are small clusters of earthquakes and volcanoes in South Italy and Iceland, and there's chains of volcanoes and linear bands, you know, talking about these ribbons, these bands, these clusters around the Ring of Fire, around the Pacific Ocean, and then you sometimes have these hotspot volcanoes as well. Remember, use your keywords, make sure you really, really know what they mean. Another question, just going to run through this one very quickly. Outline the differences between conservative and destructive plate margins. So this is your convergent and divergent plate margins. So you need to talk about any 2 differences. All right, so plates move towards each other at a convergent or destructive plate margin, whereas they move side by side at conservative, okay? The denser oceanic plate is subducted, no subduction, okay? Land is destroyed, no land is destroyed, all right? So you can talk about any difference that you want, okay? Another quick question, suggest how hazard risk would be affected by an increase in population, okay? So it's likely to increase when there's an increase in population because there is a potential for more people to be vulnerable and therefore the likelihood of death increases. An increase in population means more housing, therefore potential for damage and destruction. And an increase in population could mean due to cost or availability of resources. Okay, all right, so there's some answers there for you. And then I've left the meaty question right to the very end, a 9-mark question here. Okay, this is fantastic for us geographers to really show that we can think like a geographer and actually to sort of like support our answers with keywords. All right, so to what extent does a country's ability to cope with the effects of a tectonic hazard depend on its wealth? And then it's asking you to use examples to support your answer. Okay, so you've really got to look at, I'm sorry, this is very, very lengthy. I'm not going to go through it all, but this is really where you can go to town, look at the people, look at the medical facilities, the education facilities, the monitoring, the prediction, all right, how they can cope, whether corruption might be something. So looking at the political side of things, okay, looking at LICs, HICs, all right, and then really looking at sort of like the population, the building density, maybe even the time of the day or the year. Okay, so I'll leave that on there a minute, just that you can either screenshot that or take a photo of that. Okay, so a couple of questions that I've had here. It says, to what extent is the San Andreas fault a problem? I don't know. You know, it is a major problem. It's apparently overdue for a major earthquake. I would say that that particular area of the world is quite densely populated. So, you know, I think it is a problem. But to what extent, you know, you really need to think about sort of like when, where, how, why, all stuff like that. You know, are the Americans prepared for an earthquake? Do they have sort of like a monitoring system? Do they have a preparation system? I think they do. So it's a good case study to look at. Can tectonic events be helpful to some people, especially agricultural farmers? Yes, it can, and that is really something that we do look at tomorrow. Because, you know, agricultural farmers, when you're looking at the fertility of soil, it really does influence that. Okay, so that's a question. There was one question about forest fires, which I will try and come back to sort of like later on. I know we were trying to focus on volcanoes and earthquakes particularly. I'll try and come back to that question later on. Okay, so our closing thoughts really on today are that we've looked at what natural hazards are. We've looked at the types of natural hazards. We've looked at the factors affecting risk, and we've looked at earthquakes and volcanoes, plate tectonics theory, the distribution, and looking at plate margins. We've also looked at different types of questions and how you can use your key terms to actually, you know, your keywords and your key terminology to really write like a geographer, and how you should really start to think like a geographer in terms of sort of like looking at the social, the political, the physical, the environmental side of things, looking at HICs and LICs. And having those 6 9-mark questions really is a joy. I know some of you really sort of like get daunted by that, but don't. Okay, really, you know, make sure you know your stuff and then show the examiner that you really are a fantastic geographer. Tomorrow night, we are going to focus very much on Iceland in terms of a case study. We're going to look at Eyjafjallajökull, the 2010 eruption, look at the impacts of that on a short-term and a long-term basis. We're also going to look at how Iceland prepares for earthquakes and monitors and plans for earthquakes and volcanoes as well. They have a very sophisticated planning, preparation, monitoring sort of like system in Iceland. So it is a fantastic case study. And also the reasons why people continue to live in an area of sort of like a hazard. And again, Iceland is the perfect case study for that. So we're kind of combining 3 or 4 topics within one case study. And there's another question that's quickly popped up. Why does Japan have so many earthquakes? It's because it's on the Pacific Ring of Fire, okay? So therefore, because it sits on a destructive or a convergent plate margin, that's the reason why it has so many earthquakes, because the friction builds up, the pressure builds up, and then obviously you get this shaking of the plate. Okay, so before I leave you, I don't know if you've got any more questions that you can just put into the chat box if you have, or if not, you can email me afterwards. That's absolutely no problem at all. As I said, tomorrow, 8 o'clock, we will be looking at the case study. I hope you have a really good rest of the evening. Be kind to yourself and to each other, and I will see you tomorrow. Thank you very much.